Hello everyone, welcome back to my YouTube channel. This is Paranka here. In today's video, I'll be discussing about the fabrication process in VLSI. Before going to the process, I'll be discussing what is VLSI and what is fabrication process. VLSI involves integrating millions of transistors on a single chip. VLSI is very large scale integration. Fabrication process is crucial for creating these complex circuits. Aim of this presentation is to understand key steps in VLSI fabrication. Fabrication steps are design, masking, etching, deposition, and testing. Coming to the design, circuit design using CAD tools. We'll discuss each of the steps in deep. First step is circuit design. It is a very crucial step in the fabrication process. Preceding the steps I listed earlier, here's an overview of the circuit design process. Digital design, it creates a digital circuit design using hardware description languages like HDL, like Verilog or VHDL. And also it converts the digital design into a netlist, a list of gates and connections. Placement. After doing all this, it determines the optimal placements of gates and components on the chip. Uh, then connecting the components using wires, taking into account timing, area, and power constraints. Um, it also creates a physical layout of the circuit, including transistors, diodes, and other devices. And it also verifies whether the design is correct, whether it is functioning properly, and its performance. Uh, then it finalizes the design and prepare it for the fabrication. The output of the circuit design process is a set of masks which are used in the fabrication process to pattern the layers of the chip. So the output of the circuit design is masking, which becomes the second step. Um, what is masking? Masking is the process of transforming the circuit pattern into the semiconductor wafer using a physical mask. We have different types of masks and the photo mask and reticle masks. The process will be like creating the mask from the circuit design. After that, you need to clean and coat the wafer with the photosensitive material photoresist. Then you have to expose the wafer to UV light through the mask, creating a patterned image. Then develop the photoresist to reveal the pattern. Use the patterned photoresist as a mask to etch the underlying layer. Then comes the stripping. So this is what like it is repeated for each layer in the fabrication process, building up the complex circuitry uh, in the integrated circuit. So it also includes photolithography process and creation of masks for different layers and well metal layers, precision in defining features. Coming to the next step, etching. Etching removes unwanted material from the wafer. Also, like it removes layers of the material from the semiconductor wafer using chemicals or plasmas. Again, we have different types of techniques. Also, its applications like let me explain you the process before that. Layer preparation, mask definition, etching, pattern transform, and etch stops are the etching process. So the uh, process is like prepare the layer to be etched. Like example, to deposit a mask layer. Then define the pattern to be etched using a mask. Then expose the wafer to the etching medium like the chemicals or plasma. Then transfer the pattern from the mask to the underlying layer. Stop the etching process when the desired depth is reached. So this all includes the etching process. What does deposition do? Deposition is like it adds materials for interconnections, and also it is a chemical vapor deposition CVD or physical vapor deposition PVD. It like PVD and CVD. I'll be explaining you after the slide. Building conductive and insulating layers, creating wiring and contacts. In chemical vapor deposition, what happens is a chemical reaction is used to deposit material from a gas onto the wafer. And in PVD, material is vaporized and then deposited on the wafer in a low pressure plasma chamber. And also there is another process like it is called as ALD, a slow and precise method in which a precursor material is deposited on the wafer surface and then reacted with another material to form the desired material. So basically, it is used to create thin films that make up the insulating layers, conducting layers, and other components of the semiconductor. Next comes testing, which is the last step of fabrication process. So this is testing ensures that uh, manufactured chips meet the desired functional and performance requirements. So yeah, here there are two types of testing: electrical testing and reliability testing. This is functional and parametric, and reliability is temperature and voltage stress. So this will test the efficiency of the pattern, and it also yields the analysis and defect detection. So what happens is in functional testing, that is electrical testing, it verifies that the chip performs its intended function. And in performance testing, it checks the speed of the chip, its ability to consume power, and other performance parameters. Reliability testing, it ensures the chip's reliability and durability under various environmental conditions. Also, like there are testing types like wafer level testing, package level testing, system level testing. And also the methods are of three types: automatic test equipment, scan based testing, built and self testing. So the testing steps, like what happens is they create test patterns to exercise the chip's functionality. Then they check the testing for application, like they apply the test patterns to the chip, and also they collect the response analysis, analyze the chip's responses to determine pass or fail. Then it analyzes the test data to identify trends and defects. Testing is a crucial step in ensuring the quality and reliability of VLSI chips and is performed at various stages of the fabrication process. So this is about testing. We've discussed five types of, five fabrication steps like design, masking, etching, deposition, and testing. So coming to the summary, VLSI fabrication is a complex process involving multiple steps. Each step is critical for producing reliable integrated circuits. Continuous advancements improve efficiency and performance. So this is all about our presentation. Also, we've discussed about fabrication process and its steps, which is present in the very large scale integration, and also its steps includes design, masking, etching, deposition, testing. Some are like a chemical, mechanical polishing, final testing, packaging, uh, and doping, etching, uh, circuit design, mask creation, water preparation, layer deposition, lithography, etching, doping, metallization, chemical, mechanical polishing, testing, packaging, final testing. This summary covers the key steps involved in the fabrication process from circuit design to the testing. So this is about today's presentation. If you find the video helpful, please do like, share, and subscribe. Thank you.